Hello everyone. This is sixth section of the Numpy tutorial. So in this section, we're going to practice linear algebra concepts. That means how to use Numpy for linear algebra related calculations, how to do the random number generations. What are the packages available in Numpy that can generate random numbers, and what is pseudo random numbers, how we can use that package to generate the random numbers and the related operations. And then broadcasting, what is broadcasting, and random walk, those kind of concepts that I'm going to cover in this section. So let's start with the linear algebra. So linear algebra is like any matrix related multiplication or decomposition, or finding out the determinants, or square matrix related math. Okay, so for all these things, Numpy has a special package, okay, that we can do all linear algebra related operations using Numpy. Okay, so actually before Numpy, MATLAB was very popular in handling any of these kind of matrix related operations, but right now Numpy and pandas work together that can do a lot of complications operations in a simple way using different kind of packages. Okay, so let's start with the sample matrix related operations. Okay, let's import Numpy. So I'm just going to create two random matrices. Okay, I'm going to print out what I have created. Okay, now we have two matrices. One is 2 cross 3 and another one is 3 cross 2. Okay, so both are in different dimension, different shape, and these kind of operate. This size is perfect for performing matrix multiplications. So if you're familiar with matrix multiplication, you can see 1 into 6, 2 into -1, 3 into -8, and then 4 into 23, 5 into 7, 6 into 9. So that's how we will do the matrix multiplication. So we can do the matrix multiplication on the matrix of dimension 2 cross 3 and 3 cross 2. Okay, so how can we do this matrix operations? We can do it in two ways. One is print x dot y, and then another one, or you can do it as np dot x comma y. You can see both will give you the same answer. So 2 cross 3 and 3 cross 2, that always normally will give the 2 cross 2 as a result. You can see both gives the same result. So Numpy has a package called linear algebra package. Okay, we can import that package to perform find out the inversion of the matrix, determinant of the matrix, or rank of the matrix. Those kind of matrix related numbers can be obtained by using that. Numpy.tab, you can see algebra. You can see linear algebra, this one. So this package, from this, I'm going to import inverse, then quadrant, and determinant, and then matrix rank, x equal to np dot random dot. I'm going to create some random integer. For that, I'm going to call random n 5, 5. So I'm going to create a matrix variable where x transpose t dot x. Okay, So we are doing the dot operation between X and the transpose of X. Okay. Means 2 cross 3. When you apply transpose, then the 2 cross 3 matrix will get converted as 2 cross 3. Okay. For example, let me show you. Here X is that, and when I do X dot T, so you can see this 2 cross 3 is getting converted to 3 cross 2. We could just get the transpose. So always the dot operation you can perform when the opposite column, the number of rows in the first matrix is equal to number of columns. In that case only we can do the dot operation. So we are just converting the matrix and the transpose of the matrix. You can do the dot operation. Okay. So now if I try to display the result, you can see random number generation. Okay, now I'm going to find out the inverse of the matrix. Okay, and then determinant of the matrix. Okay, it's determinant of the matrix, and the rank of the matrix can be found out by calling the matrix rank. See, it is rank of the matrix. Okay, so if you want to know more about linear algebra related operations, what are the operators, what are the methods, all those things, the equations, everything that is related to linear algebra, you can find out the documentation in Numpy to explore more. Okay, so now we are moving on to the next concept, that is random number generation. So random number generation is kind of particularly, even you can do the random number generation related operation in Python itself, but in Numpy, they made it very easier with a lot of different packages available. For example, the rand package will generate random array with a given shape. The distribution will be between 0 to 1. For example, okay, let me give a sample for that. Rand, simply rand function. So if you pass the values as a parameter, then it will just create a 2 cross 3 matrix with a random number 0 to 1. So always that this random function will generate random numbers between 0 to 1. Okay, when you pass these parameters, that will take it as a matrix size and will generate it. Let's create one more of this. This time we're going to create 4 cross 4. You can see random number in the 4 cross 4 size between 0 to 1. Similarly, rand n, that function will generate random array with the given shape. The standard normal distribution between the mean value should be always 0, and the standard deviation value will always be 1 for that created matrix. So that is called random number rand n matrix. Okay, so numbers from normal distribution with 0 mean and standard deviation 1. So always the created matrix will have the 0 mean value and the standard deviation value is going to be 1. Okay, so that is about rand n. And rand int is a function that will generate random array with integer data with given shape. Okay, so that is rand int. So let's create some matrix using rand int function. Okay, so this one I just get the higher value, the vector value of that. Okay, maybe let's create a rand int with 2D array. Okay, 1 to 100, 2 cross 2 matrix. You can see from 1 to 100, between 1 to 100, it will just take 4 values of size 2 cross 2. And do the same thing with 4 cross 4. You can see 4 cross 4 matrix of size 1 to 100. So this is random number generation. Okay, so you have 3 functions. One is rand, and then randian, and then rand int. Pseudo random number generation. Okay, the random number actually that will generate based on the seed value. It will take a seed value. It's a big concept that it's kind of it needs a separate class to explain the pseudo number generation concept. It's like it will take a seed and randomly will move away from that seed and expand that region around that seed based on randomly selecting some values. That is the concept called pseudo random number generation. So the main concept of pseudo random number generation is it will, it will just take a seed value and it will just expand based on the seed value. Okay. So for example, there is a function called normal function. So from the random number generation package, I'm just taking the normal function with a size 4 cross 4. It will generate any kind of samples. Okay, now I'm going to explain the seed concept. The random package has a package called seed. You can just pass any seed value. It will automatically create a, maybe I will just save it in a variable and show it. So it just takes 1, 2, 3, 4 as a seed value. Okay, so Numpy has random package, random has rand state package. You can generate seed pseudo random number either by calling random state function or seed function. Both will work for this kind of pseudo random number generation. Okay, it will take the seed value as a parameter, and then that will be all the sample values will be saved here. Now you can see I'm just displaying the values. Okay, so if you want to know more about the random number generation concept, I have given the link for that. Okay, so you can just expand what is rand int, and rand. Okay, so you can try all the different possible options and learn more about this random numbers and pseudo random number generation concept. Okay, now next I'm going to explain few more matrix related operations. Okay, so I'm just creating a variable with this random number randian concept. I'm just creating a data with a matrix of size 2 cross 3. And I can do the element-wise multiplication on this simply by multiplying each value with 10. You can see 0.47, if you multiply it by 10, then it is 4.7. And you can do the element-wise multiplication operation as data cross data like this. Okay. And then you can do the apply the, let's do few more operations by creating 2 matrices. Matrix 1 with the array package is not defined. Let me call it first. So I have just imported that random int package as an array, and I have created 2 matrices of size 3 cross 3 between 1 to 9 with 10 values. So 1 to 10, 9 values. Okay, I have created 2 matrices, and it's getting this side. You can see the first matrix and second matrix. Okay, so now we're going to do some more operations on this. Okay, so let's do matrix multiplication of these 2 matrices. Mat 1, element-wise multiplication of mat 2. Two into 6, 4 into 2, like that. And then addition and multiplication. Let's do the addition first. Okay, 2 plus 6, 4 plus 2, 6 plus 2, like that, element-wise addition. And for multiplication, for element-wise multiplication, you can either use this symbol or at symbol, start symbol or at symbol. So this will do the element-wise multiplication, that symbol. So you can just explore what this at symbol means. Okay, next we'll do some not a number related. Anything divided by 0 is infinity. You can see Numpy handle it as infinity. So some numbers, Some languages will handle it as not a number, but NumPy can do it as infinity. Okay, now let's do some 3x linear algebra related operations. Okay, 3a minus 2b. So matrix 1 and matrix 2. And then let's do some cube. And then the cube can be done as power. Okay, so these are some matrix related operations. Next, broadcasting. So NumPy operations are usually done on pairs of array on element based on the element by element operations. Okay, so in the simplest case, the two arrays must have exactly the same shape. NumPy's broadcasting rule relaxes this constraint. Okay, when the array's shape meet certain constraints, when they operate on two arrays, NumPy compares their shape in element wise. It does that comparison. It starts with the trailing dimension and works it like moving forward. Okay, the two dimensions are compatible when they are equal, and one of them is considered as 1. Okay, so this is called broadcasting concept. Okay, so it doesn't matter whether they are in the same shape, which should be the case for the normal Python and other languages. But when you use NumPy, you can just bypass that constraints. Okay, I'm just if I call this, I'm just creating 4 plus 4 and adding 100 to each values. And if I display, you can see same. Okay, now I'm going to create a row of values with single dimension array. Okay, and then if I print, and you can see it is a simple array. And then now I'm going to do some operations on this 1-dimensional array and this 4 plus 4 array. So when this is 4 plus 4 array, and this is 1-dimensional array. So when I add this, you can see 1, 0, 0, 100, and 102 and 105. Okay, so let's do one more with transpose. Tab, add columns. So you can see how it is converted as from row to column. Okay. Okay, so those are some linear algebra related operations. Now let's see, we have almost seen some in these all 6 sections. We have seen what are the popular packages, what are the things that we can utilize in our problem solving, those kind of stuff in different aspects of NumPy packages we have practiced. Okay, so now let's see an example to show you how NumPy can improve not only it has a lot of functions, lot of packages that makes the code easier, that can help us to do complex operation, but also we are going to see the efficiency of the operation, okay, through a simple example. So for example, let's create range functions. Okay, let's create some 100,000 values. Okay, a big operation because I'm going to see how much time it is going to take to do this operation. Okay, so to calculate the time, I'm just going to see hash time, the parameter time for in range 10. So this my array. So I'm just going to take this 1,000, this big number, and then I'm going to do the double multiplication on each number. Okay. So now I'm going to print this my array 2. I'm going to save this in my array 2. And this hash time, this percentage time will give you the time, total time, 10 minutes, 10 milliseconds. So when I do this operation using NumPy, that means I'm creating 1,000 numbers, and I'm just multiplying all these numbers with 2. And the whole process time, it just takes 10 milliseconds. Now I'm going to do the same operation by using raw Python. Okay, by using list, If it is list, we have to use range function. If it is NumPy, it is a range function. But if I do it with raw Python, I'm using a range function. Now for the same operation, if I have to do with the raw Python, then you can see 561 millisecond. Okay, so you can see the time difference. It is 10 millisecond, it is 561 millisecond. Okay, so not only in terms of number of packages, the availability of the packages, but also with the time, with the efficiency, the performance. There is a huge performance difference between the NumPy and raw Python. So both in efficiency wise and the usability wise, using NumPy has a lot of advantages. Okay, so next I'm going to just explain a very a sample problem called random walk. Okay, so we're going to code a simple program to using that random number generation. So with the random walk concept. Okay, so this random walk concept, we have to imagine like we are walking, we're starting from somewhere and walking in any direction, randomly or changing direction, and then moving in any number of steps in any directions, and we're just going to see where we ended. Okay, so two concepts: randomly walking in any direction with any number of steps. So in this case, the direction is chosen in random manner. At each step along the way, we can choose 2, 4, or 8 directions. It depends. Okay. To make it simpler, let's first consider 2 directions. That means to go up or down. Okay. We can say that up, down, left, right, or 8 directions. But for simplicity, we'll consider only 2 directions. Numerically saying +1 and -1, moving upward, moving downward. So real world example. So let's see how we can use random number generation and solve this problem. Okay, in real world example of this random walk has huge number of scientific fields, including ecology, psychology, computer science, chemistry, biology, economics. So random walk is actually traced by let's say that in the physics we are tracing the molecule. Okay, the travel of the molecule in a liquid or gas, the search path of a foreign animal, the price of the gas or financial status of Ambler, anything randomly, whatever we can do, we can select this random walk application and try it. Okay, maybe I'll show you a very simple problem with 2 directions. I'm going to import random. Okay, and then let's say the position where we are starting it is 0. And then walk position, we're just assigning that. Okay, and the steps. Okay, so with this steps, 1,000 steps. Temporary variable is attempt step, and 1 if random dot rand int 1 else -1. So for each step, we are moving the directions. Okay, 100. So 1,000 steps, we're just plotting some 100 steps here. Okay, any random 100 starting from 100. So let me import the MATLAB lib for this. It's a visualization library, as I explained in the previous video. We will see it in detail later on. As of now, since it has 1,000 points, it is hard to visualize. So we are using the MATLAB library to visualize. Since it is random, every time you run it, the size and the graph will be totally different each time. Okay, you can see each time I run, it will give different value. Because it randomly selects values starting from any positions. There is no a particular criteria. It can go up, it can go down. Okay, so this is called random walk scenario. Okay, so that is the end of section 6 video tutorial, and that is the end of Numpy video tutorial. Okay, so in the next video tutorial, I'm going to teach you pandas. Thank you.